First of all, thank you for being here. My name is Fábio, and I'm gonna talk to you about our journey of scale at N26. So I'm a developer at N26. For those of you that don't know what is N26, we're basically a digital bank. We have no physical branches, and we're trying to become the bank that the world loves to use. And what is really important for us is to make banking beautiful and provide you an easy way to manage your finances. For example, using Spaces, which is basically our sub-accounts feature that you can see here in the screen. And coincidentally, is a feature I work in, so I want to showcase it. So let's really start. During the last year and a half, N26 went into hypergrowth mode, which means, according to the theory, that it had at least an annual growth of 40%. As a good example of the crazy ride this last year has been, when I joined the company in February 2018, the general Slack channel had around 400 persons, while now it sits around 1,400 persons in just under a year and a half. But for now, let's focus on the Android team reality. This long journey started in October 2014. That was when N26 was born. At the time, as a new startup, nobody suspected how big we would become, and we had a pretty much regular Android development between 3 or 4 developers that had to code in a fast way to prove the concept. But then, in 2016, we got our banking license. This was for sure one turning point, and it was the moment that we understood that we eventually would scale and had to do a bit of preparation for it. So during 2017, we set up the stage to it. And by 2018, we laid out a plan to grow and started hiring. And by the end of the year, we were around 14 Android developers. But the growth continued, and right now our team is made up of 27 developers. And what is interesting here is that if you take a look just to the last year and a half, we got a growth of around 500%. And as you can imagine, growing that fast in a small amount of time is not an easy task. Also, what is pretty interesting is that out of this huge team, only 3 or 4 members had experience working with Android teams larger than 5 developers. So basically, this is a new challenge for everyone, and we are all newbies, and we have to figure out along the way. So what I want to talk to you about today is what comes with scaling the team. And I could easily talk for a couple of hours on everything that this scale comes with. We could talk about a number of topics: onboarding, recruiting, automation, releases. However, I'm not going to talk about this. I'm going to talk about technical readiness. And what do I mean by this? Every time your team grows, you feel changes. And with it, some failures on your technical structure can start to show up, and some bottlenecks will become more evident. Also, you will start to see some issues arising when trying to maintain quality and consistency in the product that you want to deliver. However, as long as you have technical readiness, and be mindful about your team's approach to code and modularization, testing, and design, you should have a more or less steady road to the growth of your team and your product and your organization. So let's start off with the basic and how we approach code. And let's start really, really simple. Our base principle when it comes to code follows the broken windows theory. According to this theory, the probability of a building to get a broken window when it already has another broken window is way higher when compared to a building that is in perfect conditions. This way, if you don't fix the broken window in your building, you'll see that the building will degrade itself rather quickly when compared to when you actually fix it. So if we apply this theory to code, we can say that a good-looking code base has way more chances to keep high quality than one that lives in chaos. And it's not just about the beauty and satisfaction of working on such a code base, but it's also a sign of excellence and attention to detail. So when dealing with such large code bases, it's imperial to provide shortcuts, no shortcuts or hacks in order to get features shipped. Because if that happens, you'll basically see a disease spreading and spreading on your code base. And when you have a code base that is around 600,000 lines of code, when you notice that this disease is there, it's basically too late to fix it quickly. It will take years for sure to avert the damage done. So what about architecture? This is for sure always a highly debated topic in any team. And in my view, what is crucial to keep in mind is that there is no perfect architecture, and there are always trade-offs to be made. What you have to have in mind then is that a good architecture will provide an easy way for your team to develop features quickly, even when time and accumulation of business requirements come into play. In my view, there are 4 crucial points that your architecture should take into account. So one is reducing the number of discussions and decisions. A good architecture should move the discussions out of the way so that we can develop a feature with less problems possible. Also, it should contribute for the onboarding. If your architecture defines good guidelines and limited openness, it will actually be easier for new joiners to come in, and in the second day of work, they're already contributing. And it feels really amazing when you have people coming in, second day, PR is merged, and they already contributed. And another point that your architecture should take into account is embracing evolution. Your architecture is not perfect for sure, and it will be not right at the first try, so taking these into account when building. Start versioning, because when you scale, you will see different parts of your app with different styles of architectures. Another one is, of course, favor testability. So, as testing is one of the pillars of every good app, you should take into account when you're designing your architecture. And it should protect from making mistakes. With time, your architecture should go in the direction of becoming more and more robust and prevent you from doing more and more errors. So with this being said, let's take a look to some core ideas of our architecture. So if you did an X-ray to our app, you'll basically see that some core ideas of our architecture are reactive, layered architecture, and dependency inversion. So starting off with the reactive paradigm, let's take this simple, hopefully simple example where the user is on the Spaces dashboard screen. So again, for context, this is our sub-account screen. And basically, it taps to check the details of their main account space. That first one in the left. So at the time, they receive an incoming transaction of 10 euros. What will happen is basically a call to the Spaces microservice will be done, and it will reply with information about the user spaces. So space 1, space 2, and space 3. They are then put in the Spaces store that, due to its reactive nature, it will disseminate the information to the other observers. In this case, it will be our space details view model. So in the end, the information will spread until it gets to the main account and basically updates the balance. The magic here is that in parallel, while the space details screen is being updated, the same will happen to the previous screen, the dashboard, because the information will be spread to all the interested in this kind of data. So basically, it will go from the Spaces reactive store also into the Spaces dashboard view model, and then it will follow, so that then the balance below the main account gets updated. We can see then that with the reactive approach, we can reduce our need for synchronization in your code base, as the data is pushed naturally to all interested, and they can react appropriately. So in the end, this will create a simpler code base that has less problems to deal with the fast influx of incoming requirements. So with the reactive explained, let's see about layered architecture and how it favors a scalable team. So this is one of the most well-known principles, and that says, of course, a lot of its value. And by splitting your feature in well-defined layers, such as domain, data, and presentation, what you get is like, you first clearly break down your feature into different responsibilities and promote loosely coupled components inside your feature. In consequence, you'll be able to safely refactor one layer without affecting the other, and you also get the ability to different team members work on different parts of the app without clashing each other on each other's work. Also, it's nice if you define your dependencies following the dependency inversion principle, where that says that high-level modules should not depend on low-level modules. The reason is that these high-level modules, such as domain, should be the core of your app, and they are less prone to changes when compared to outer modules, such as presentation and data. Moreover, it promotes reusability of core domain logic. And finally, dependency injection. Logically, after you define your layers correctly, you want to glue them all together in some way. By using dependency injection, you will get these needed dependencies created and injected in your components, creating this glue between different components in the app. Also, if you're using dependency injection correctly, you are probably using a nice architecture that promotes testability of components because they are loosely coupled. I also wanted to add that in big projects like we have, it's handy to do it with a library that does compile time checks. Because in an app such as ours that has around, last time I checked, 500 activities or fragments, it's not really reliable that we do this kind of checks in runtime. Because basically, to guarantee that everything is working, we would have to run to the 500 plus possible flows. So after this overview of values that promote scale, let's see how you should approach integrations with third-party SDKs and how you should define your tech stack. So in my opinion, you should really have a really ruthless approach about how you define your tech stack. Every time you think about adding a new library to your project, you should do the following questions. Which problem is it solving? Do we really want another annotation processor on our project? How will build times be affected? Is this a solid technology? How active is the community around it? And what is the impact of it? And is it actively maintained? So if you jump headfirst into the hype train or don't do a solid work on evaluating this tech tool, you might end up in a really tricky situation. I have a good example that due to a partner that we integrated with at N26 that provided a transitive dependency of OKHTTP, we were stuck in a version of retrofit that is from 2016 for 2.5 years, which was an older version that made us write worse code and create more legacy. And in tech, 2 years is a lot. If you think 2.5 years ago, Kotlin was not an official Android language, RxJava 1 was just out, and Butterknife was still a thing. So we, being a bank, have to be ready to jump on the most secure tech stack at any time. And in which position would we be if some crazy security exploit was found on retrofit or OKHTTP? For sure, something really bad would happen. And using this conversation about third-party libraries, I just want to do a side note about that the fact of wrapping them is actually good. Just follow me. So being a bank, as I said, we are of course highly regulated and we need to be able to respond to requirements that come from regulatory organizations without warning. And last year we had some problems with our sign-up flow and we needed to improve the quality of our features. So basically these would come with a camera library change. The first problem was that actually the camera interactions were not abstracted at all and everything was coupled between the camera lib and the app. For that reason, of course, we had a hard time and weren't able to just jump in and fix the problem easily. First, we had to define then a camera abstraction and put the original camera behind it. And only then, we could actually integrate with the camera lib too, which should fix a lot of our problems with crashes and blurry images. We can only conclude that due to this initial huge coupling between the camera lib and our code, we were just slow and not able to respond to the incoming requirements. But picking up with the story, I also want to talk a bit about how to keep your code flexible after the release, which enables teams to control the full feature launch and not rely on constant releases. So resuming, by the time of launch, we released the app with both implementations packaged. But with the camera lib 2, so the new one, being the one chosen by default. We started the rollout, observed the behavior, and the crash rate improved dramatically. But then we had our partner of the sign-up flow saying, so basically the pictures are getting to our servers, but they have no metadata. So something was wrong. Users couldn't sign up in the app, and basically we just lost a bunch of users because they won't download the app again. So what we had to do was basically switch the camera lib on runtime using Firebase feature flag, and the problem was contained for a bit. So even that the quality of the images with Camera Lib 1 was not that good, at least it worked for the majority of the cases. And then we resumed back on fixing what was happening in Camera Lib 2, and eventually we released it. So regarding branching and workflow, before our team expansion, so when we were 3 or 4, we could live with having Lucia, which is one of our team members, doing relatively small branches for a feature, and then me, giving a really bad example, could create a huge feature branch with no endings. And this eventually could be merged without much hassle. The problem is that when you have Omkar and Mustafa and Ilke and 20 more persons to it, things could be really chaotic if there are no rules or structure. So you have to take into account that at this scale, and this is a true story, when you pull from develop after 1 day of work, you're basically outdated on 220 commits. And this is old data. Now it's more. So, okay, it's overwhelming, but still it's easily fixable. Basically, how to avoid all these merge conflicts. It's simple rules. We just branch out and branch in small chunks. Your PRs should not have more than 1,000 positive or negative changes. If they do, your team member will rightfully say, please break down this PR, I won't review it. And nobody can take this like personally, because it's just exhausting for everyone involved to review big PRs with a lot of iterations, and the bigger they are, the bigger are the discussions, and the bigger is the time to basically merge it. So also, if you're developing a big feature that will take a couple of weeks or months to finish, you don't do a feature branch. You do a feature flag, can be locally built flag or a Firebase built feature flag. Implementation-wise, we really don't care, as long as the code is always merged back to develop. So another improvement regarding our workflow was about the commit messages. Before, we had unstructured messages that provided no value in case you were looking at some issue with a line of code. So new transaction details, new transaction list, work in progress, nothing, okay? Basically, if you try to find a bug that was introduced in this commit, you couldn't find what was the goal of this task, why was this commit done. So basically what we did is also really simple, was to use the Jira generated ticket numbers to create a more auditable code. We created this Git hook that basically would follow your dev workflow, will check out your branch, check the ticket number on the branch, add stuff, commit, and then basically it will generate the commit with the Jira ticket number. This is really simple but provides a lot of value because first, you can find your PR, the description. Sometimes they are not super descriptive, but at least they point you in the right direction, or even you can just go to the Jira ticket and understand what the hell was the story about and try to reason why this bug was created or not. So, modularization. I need to take a step, because this is going to be a big one. So, as most of the apps in 2014, we started out with a single module app. And that story kept itself along 3.5 years until we reached 2018. At this point, we were hiring, growing like crazy, and we started thinking about some problems that we had with this monolithic structure. So one of them is that when you have a single module app and you start out with a small team, you can see a number of concepts appearing naturally in your code. For example, you could see concept of user, concept of login, and as you start to add and time goes by and more concepts appear, the app will become slowly more complex. Requirements in time, you can see more and more connections appearing in your code. And the thing is that when you have a big team working on a single code base that has no boundaries, the odds are high that you will be creating connections that are not so explicit, and that the joint work of a lot of developers will end up creating hidden coupling, which of course is problematic if you want to scale, promote separation of concerns and responsibilities, and be able to do fast changes in your code base. So we had to solve this situation, of course, because this was all a mess. The clear solution was modularization. Our initial approach to modularization was by breaking down the feature into 3 modules. So let's take the example of transaction. We would break it into 3 modules corresponding to every architecture layer: domain, data, and presentation. Then naturally the app would depend on the presentation layer of the transactions. We would then do the same for a number of features. And our initial assumption was that we would have scenarios where one feature domain would need the domain of other features. For example, if you want to display transactions on the spaces sub-account feature, we could have to use the transaction domain. And so our modularization journey started until beginning of 2019, where we reached 100 modules. By the time we realized we did something wrong. Our initial assumption that there would be this line between crossing modules was wrong, because it didn't fit our technical vision, where we have standalone features that are fully installable and don't depend on each other. So we actually started merging back the layered modules into one. This way, we see our modules as totally independent components that communicate only with the service that they require data from. So by any case, for instance, our spaces feature requires some data from transactions microservice. What would happen is that it would communicate with the backend for front-end service. So all the hard logic of aggregating the data and putting it as we wish will be done in this service. So the spaces feature will still continue super simple, and all the joining of data will be done outside of the app. And so we started working slowly into merging back the modules, but we're still growing, so the trend doesn't go down that much. And I actually counted today, and I think we have 104 modules right now. And with modularization talk, usually people don't think about scale, they think about build times. So let's talk about it. It's an interesting talk that I can tell you about build times. So around 2014, we had 1.5 minute, 1 minute and a half, and basically it grew naturally until January 2018. We basically are developing an app, it's getting bigger. We have butter knife, dagger, all annotation processor. But in 2018, we started hiring, as I said, of course, more code, and basically you'll see when it increases, it's gonna stop. Okay, stop. 7 minutes of a clean build. It stabilized a bit, you see, modularization effort, working. But what is interesting is that in April 2019, we observed a drop, around 40%. And basically, what happened is that we got some upgrades. This to say that while we all love big engineering problems and finding good solutions, sometimes it's just helpful to just buy some big machinery and help us move faster at a cheaper cost. This way we can work twice as fast to find out why our builds are so slow. They're good. This is a happy ending in the end, I can tell you. So we're still not happy with 5 minutes, of course. So we have to do something. And what we did was feature launcher apps. And this is what you can get from modularization. So basically, before, if you're a developer in the credit team, and you are developing your new feature, your new sprint, and basically want to test out your things, you'll have N26 apps depending on credit, and you will compile credit, but you also compile the other 104 modules. And this can be easily 1 to 5 minutes build time, and 1 minute is extremely optimistic. So what we did was basically we just created a launcher app for these new modules that are all well modularized, no dependencies on anything, everything as it should. and what this creates to you is basically 15 seconds build time. I don't know how much percentage of decrease this is, but it's too much. It's really good. Basically, you feel productive again, and you don't even have time to switch to your browser and check out anything. Yes, no more excuses. So, to finish modularization, this is a big one. I don't want to say mistake because we didn't really have another way, but when you do apps in legacy monolith style in 2014, what you usually build with Dagger was something like you have an app, and then you have a top level app component and the user session component that depends on it, and then your features will try to depend on this user session component, and basically you have this graph like this. The problem is that when you modularize, things will start to break, because if now we extract the credit and spaces feature from the monolith app, you basically end up with your credit component there, spaces component here. And if you focus on the credit component, you will be seeing the credit component thinking, where the hell is my user app component? Basically, there's no connection. So what you have to do, and this is hard work, is that you have to extract the user session component and the app component from the app and put it below from a bottom level module. This seems easy when I talk. When you have a big app, this is really, really hard. And this is a long process. This is why we have a lot of modules, but maybe we have 10 or so modules that they can do these feature launcher apps because they are already totally decoupled of this old graph, and we have to keep an old graph and a new graph. And we have to do a lot of migration work towards it. So why modularize for scale? First, you're able to create independent teams. By splitting features into different modules, they can take ownership of specific modules and become autonomous and make decisions about the future of their code. And secondly, by creating these clear boundaries between code, you can refactor more easily without any fear of creating a menace of merge conflicts or breaking other modules. In contrast with monolith apps, where you have to do full refactors in modules, you can do big architectural refactors module by module in order to contain potential problems. And creativity and innovation. If you want to stimulate creativity and innovation, modules is actually the way to go. Can you imagine a scenario where someone just proposes, okay, 500 million lines of code, let's change RxJava to coroutines. Like, this is not going to happen, of course. So what you have to do is, okay, I have my module with 2 or 3 activities. Let's give it a go to coroutines. You try it out, you make your conclusions, you present it to the team, and basically, okay, we now have a new approach. And you didn't have to stop the whole team, you didn't break anything. So experimentation is really good if you have different modules, because you can totally isolate all the things. So, testing. The story about testing at M26 is more a recent thing in the Android side of things. So basically our number of tests was really small, and in the beginning of 2017 we had 200 unit tests and no CI. So no value. They were all right. But that changed, and we started betting on the most easy way of testing, and basically we started out doing unit tests because they're easy, they provide safe refactoring, and they let you sleep at night. So our journey continued, and by 2018, July or something, we actually had 8,000 unit tests, and we feel safer, for sure. Although we were pretty happy with our unit tests, we're still having bugs, and what is even worse is that the time that we spent on regression, which was actually manual process, was really, really high. And of course it was frustrating and time-consuming process. And for me, I did it once, and I swore I would never do it again. So what we started to do, and it's not that we didn't have automated end-to-end tests, we actually had it, and we are doing using Appium, which is a technology where you can do tests for both iOS and Android, and this was started by our QA team. But there's a big problem, because and it has like around 10% of the regression automated. But it has a big problem because it's two totally independent teams. Basically, you have the QA team on one side doing your tests, and you on the other side developing. And there's no communication, different repos, different CIs, different everything, and you can break a bunch of tests as easily as changing one ID on your XML. So, of course, this has a lot of communication problems, a lot of back and forth. So what we tried was to move Appium project to Kotlin and trying to get some Android developers engaged with it. But once again, it wasn't really a good initiative because when you scale, you start understanding that usually the major blockers for anything are other teams. And the way to produce better, produce faster, and produce in a safer way, basically you own the whole process. You own the process from development to testing to release it. So basically what we did was say, okay, we're not going to do Appium anymore, and we're just going to do some functional UI tests using Espresso. And basically, our really humble journey started in January 2018, and by July we had around 400 UI tests, which seem really low in comparison to unit tests, of course, but basically we went from 10% of automated regression to 50% of automated regression. So the future is only bright when it comes to having a fully automated regression. Also related with UI testing is that we now, they provide a lot of value, but you have to make sure that they don't break. So you have two options. Either you run them every time, or you don't run them when you merge your PRs. And of course, we have to balance. We have to have a trade-off. So what we did was basically, we created this script, a shell script, that basically takes a look into your diff, takes a look into your structure of your project, and will output the modules that you should run the test, the features that you should run the test. So basically with this, we went from a potential 20 plus minutes to testing pipeline to actually 3 minutes. This was a dramatic improvement that made us able to produce a lot of UI tests for new code with confidence it still gets super fast pull request pipelines. Meanwhile, this has changed and we continue to scale, and this solution stopped being a solution. And we had to iterate again and be more fine-grained and do a bunch of, we basically built a Gradle task, Kotlin task that will do the same reasoning, but apply a bunch of heuristics to try to guess, like if I change this file, then probably this task class is the one that should be run. Of course, we have daily runs, but we want to still provide value on our CI during our PRs. So, design systems, my personal favorite. So regarding designers and engineers, our reality was that in the beginning, we had 15 designers and engineers, and basically when we went to hypergrowth, we have 80 designers and engineers. And as you can imagine, if you don't have a structure or a process, basically this is a recipe for failure. And if you have 4 different teams, iOS, web, design, Android, basically you have an infinite number of lines of communication, and things basically go wrong. So one good example of misalignment between all teams can be told by this simple gray divider that you see between each item. The conversation about this divider would follow these lines. And I bet all of you experienced something like this. The blue developer would say, is this the right gray for the divider? And the green designer would say, yes, that should be the gray we used in the other screen. The red developer said, I thought it was this one. And the green designer, I was actually using this one, to be honest. So at the end of this conversation, we realized that not even a simple definition of a divider is actually easily to grasp. So clearly the problem was that the big scale teams of designers defined their own informal contract, then other designers defined their own second contract, while the devs created their own definitions. It was clear that we all had to align so that we could sit around and basically have this design language that we all share and follow. This contract actually exists now, and it's called the M26 Cross-Platform Design System. And it's embodied in the form of our system glossary. In my biased opinion, I believe this is amazing. If you think about it, it works as a live documentation for designers and developers, and as a playground for developers when they have to do these UI components that require a lot of tuning and a quick feedback loop. Moreover, this system glossary is built using the same design language that is showcasing. The system is organized in two major ideas. The first one is the fundamentals. They define the visual language of our system and what are the ground rules when it comes to typography, color, spacing, icons, or corner radius. For instance, if you tap on the color section, you can see all the colors that are allowed in the system, their name that should reflect the use case, for example, color background screen or color background error, and their color resource name. Also, when you build a design system, you basically get things for free, such as multiple theming, which is a really big bonus. Then, once you have fundamentals, all the fundamentals defined, such as the spacing and typography, basically you can build components using them. So in this case, at the left, you have big buttons that will be using fundamentals such as corner radius, color, spacing, and then at the right, you actually have a component that is built using another component. So we have a button container that defines how we aggregate buttons that are defined on that left section. So once the design system is built, we can really, really easily build our UIs. And this is it's not a real life example, but it's pretty close to reality. So we have this space detail screen, and we basically want to show our transactions section. So first, you would basically create a list to put on a recycle view, a list of views, view entities, sorry. And basically, you would start by declaring the section header. That's this, section header transactions. Then you would define the subsection header, just passing the string to there. And then you just do the list of transaction containers. So a transaction has a source and a message and an amount. And then you basically submit this list to your adapter, and these things will magically happen. So what I can say is that if you are able to pull off a nice design system, you get really, really important benefits. It gives an amazing dynamic. You get this feeling of open source, which everyone knows it's good. You see iOS and Android developers, I'm not going to say the first time, but interacting way much more than before, discussing how we should implement it. You see Android developers actually telling designers, your designers want, sorry. We actually have this element, and you're just inventing and making up stuff. So basically, in one side of the coin, you get speed and consistency, and the other side, sorry, consistency, and the other side, you get speed. And yeah, basically that's it. I really took too much time. Thank you.
Thank you for the presentation. It was really nice. Well, my first question is, you moved part of the logic, like the orchestration logic, to the backend. In order for that to work, it means that you have full stack teams, and they work together, like you have backend, iOS, Android guys working a full stack team. Right?
So we're actually in the process of the moving, and we're giving the first steps. But our initial idea is that basically we'll do kind of this full stack mixed. It's more mixed things. So the backend will help us to set up the service, all the root fundamental stuff, and we will build the API in terms of design and in terms of what we want the app to have.
How about the backend for frontend?
It's basically that.
Okay,
And sorry, one thing, important thing is that our backend is built in Kotlin, so we can just quickly get in and build our APIs.
Okay, the other one is when you have like these feature teams, maybe at one point you will have some part of the code that's a core part of the code, like a part of the code that's shared among all the feature teams, and it's kind of a framework, and it's really dangerous for you to change that.
Yeah.
And also it will constrain the way that developers can implement new features. Do you have this core team? Maybe you have more control of whom can change the core part of the code.
Yes, for sure. We have for sure a core team that is working actively on these big topics such modularization, testing, and design systems. So these are like the big things, and architecture for sure. We have this rotation system where every developer, at least per year, it should get around 8 weeks working on core stuff. So everyone gets to try at least to say, let's do this way. You have to prove, you have to create documents to show the benefits of your approaches, because at this scale we can just change, because like a good example is coroutines in RxJava. We really use RxJava in a nicely way as it should be, so we can't just say, let's use coroutines without any evaluation and understanding how this would affect our approach. But it's totally, for sure, doable, and a lot of initiatives came from that.
So the multi-threading logic belongs to the core part of the app.
Sorry, sorry.
The multi-threading, like you have.
Yes, we have modules for framework and architecture level components.
I have a final one because I'm asking too many. It's about when you told us about the design system, you put it in a way that it felt like the developers proposed it. Just to give you a different example, at Talkdesk we have a design system, but it's maintained by the designers. So we, of course, can create libraries implementing the design system for iOS, Android, and web, but they are responsible for the consistency.
Yeah, that's a good one. So basically, in the initial phase, we had nothing. In the second phase, we tried to build our own design system just by checking all the commonalities between our different features and saying, we have this, let's build a component, that's it. But this was still a problem because the designers didn't have this contract that the devs created. So then, final phase, we actually created this task force for it, and the design team proposes the components that they feel like, all the fundamentals, but the developers can get in the conversation, and there's always like this document where it's a proposal for a component, and people can just get in and say, this doesn't feel right because X and Y, but after it, we basically put it in the glossary, and it's available for everyone. We also do internal releases with this glossary so that designers can know what's going on.
Good, thank you.
Hey, thank you very much for the talk. Just for clarification regarding asked questions. So do you have the cross-functional teams, or are they?
Yes, we have cross-functional teams.
Okay.
In N26 we are organized by the feature teams. Each feature team should have one designer, one Android, one web, iOS, product manager, UX,
Okay.
etc.
So do you have then a kind of isolation problem within the project when you
It
know
can be
that?
for sure. There are people that hold a lot of knowledge on their specific feature. We don't have a solution for this right now.
Yeah, we are neither. Thank you.
Have you considered cross-platform frameworks?
No. Honestly, I think it's really hard right now. I don't even know how to start this conversation. You have 30 Android developers on one side, 30 iOS developers on the other. Now just put 60% in this room discussing it. We're all happy as we are right now, honestly.
There's I now remembered when you put your test there, you said 8,000 tests and 8,000 unit tests.
Yes.
And how many UI? When you mean UI, you mean end-to-end UI tests?
Not
400.
end-to-end.
Ah, okay.
They can be really granular. The reason why is that since we're a bank, we have to prove that the features work. And basically we have this platform of regression that has these items, like you click in this button, something appears, something really simple, a simple use case. Basically on our unit, on our UI test, we have to map each UI test to this case. It's basically, technically it's an annotation with an ID. And when we run the regression, all of this is populated. So we have to be really granular. I'm saying this thing works for this release because we have to prove that in terms of regulation that our releases actually work for this use case.
But the UI tests perform I/O operations. They call a server or a...
No, they call a fake server right now.
Okay.
But eventually we're going to move to that. It's basically step one, and then eventually, because our Appium platform is actually end-to-end. And it had a lot of problems of flakiness and the ones you know. So eventually we want to move there also with Espresso, but it's a journey. Cool. Good? Good. Cool, thanks.